So we're going to be producing a redox equation. So this is a question that I've just produced. So chlorine gas is produced as a mixture of HCl and KMNO4, and we need to produce the equation. So we need to find out what's going to change. So we have Cl minus, that is going to turn into chlorine gas, which is Cl2. At the moment, I'm not interested in balancing the equation. We have KMNO4, so we have MnO4, and that is minus. And we need to know that goes to Mn2 plus. So you can do this for every single redox reaction. So quite often they will tell you, so they might have Fe2 to Fe3 plus, but it will tell you some oxidation states, some like the manganese, you need to know it goes to 2 plus. So the first thing we're going to do, we're going to look at the species that we are interested in, and we're going to balance its electrons. So we need to balance this mass first, so I'm going to put 2 here because I don't want to work with fractions at the moment. So 2 chloride ions makes 1 chlorine molecule. So we have 2 negatives on this side, so we must have 2 electrons on this side. On this one we have MnO4, but we are only interested in the manganese. So the manganese here, we do not know it. We have the oxygen is -2, and -2 4 times, so that comes to -8. Overall, it is -1, so X must be 7. So that means our manganese is +7. And it goes to +2, or 2 plus. So we need to reduce this side by 5. So we can add 5 electrons onto this side. Now we've balanced by electrons, we need to balance the oxygens. So it is acidified with HCl, and when we produce it, when it's been acidified, we're going to produce water. So because there's been 4 oxygens, there is going to be 4 waters. What we now need to, I'm just going to move my arrow a little bit. What we now need to do is balance the protons. Because there is 4 waters, we need 8 protons. Because each water has 2 hydrogens. So this is now balanced for mass, this is balanced for mass. So we actually have 2 complete half equations. We now need to combine these half equations to produce the final equation. They need to have the same amount of electrons on both sides. So what I'm going to do is I'm going to multiply this by 5 electrons. I'm going to multiply this by 2 electrons. So we have 10, 5, 10. And this side I was times them by 2. So 2 of these, 10 of these, got 16 protons, 2 of these, and 8 of these. And now we have the same amount of electrons on both sides. I'm now going to combine these. So 10 chlorides plus 2 manganese. I am going to add my electrons, but I'll do that last. My 16 protons plus my 10 electrons. On this side, I've got my 10 electrons, and I've got my 5 chlorines, and my 2 magnesiums, and my 8 waters. So I have 10 electrons on both sides. I'm going to get rid of these because they both cancel each other out. And what I have now is a balanced redox equation. Both charges and masses are balanced. And that is the answer to this question.